This video is intended to be the first of a short series of videos which are an introduction to V-Hab, the Virtual Habitat Simulation Program. I am Brody Lauer. I am the Environmental Control and Life Support System Sub-Team Lead for the Illinois Space Society RASCAL team for the years 2019-2020. I am not associated with V-Hab or the creators of V-Hab at the Technical University of Munich in any way, but this is a program that I am looking to learn this year to verify my own models, and I would like to also create this introduction to help other people who are learning this program. As a side note, this program is not completed yet, and many aspects of it are subject to change, so if anything is different between my tutorial and the version you are working with, that could be a reason why. So a brief overview of what V-Hab is and how it works. So V-Hab is a MATLAB program, so you are going to need to install this on a computer that has MATLAB. And what it basically does is it takes a programmed life support system that is modeled in software, and it uses that to create a series of graphs basically emulating how the life support system would function. Here is, for example, a series of graphs of total pressure throughout a theoretical vehicle over the course of one day. Here are graphs for the oxygen partial pressure in the same scenario. And through creating a bunch of graphs like this, running the software, you're able to get a pretty comprehensive verification of your life support system. So if you are learning V-Hab, I highly recommend opening up the V-Hab documentation and introduction on the wiki. It is very helpful to go through, even though some areas it is more or less helpful than others. Once you have your login information, you're going to need to go to the GitLab page. Now, just a quick note, you are going to have to log in specifically to the LRZ Leibniz Supercomputing Center GitLab. You can't just log into the normal GitLab page. I had some trouble with that when I first started running this, but that is not too big of a thing once you know. You're going to want to go to Standard if you're outside of the LRZ, and enter your username and password. I already have that done here, and sign in. So once you're there, you're going to open the steps base folder. I think mine already opened it automatically, but it may not do that right away. As of right now, that's the only project in there, so you shouldn't have to worry about that too much. Just click on the link to get here. And then once you're here, you're going to want to download it. I recommend downloading it to a zip. And then I will be back as soon as that is finished downloading. Okay, so I now have the step-space master file downloaded and moved into its own folder where I've unzipped it. And from there we can get started on the tutorial included in the V-Hab documentation. I highly recommend having this open while you're watching the video as well. It's very useful. I'm not going to go through these first 4 pages here, 1.1 through 1.4. I recommend reading it. It has some very useful information on how V-Hab works and how it's formed, but it is beyond the scope of this video, so I won't be kind of going through what that says at this point. Basically, what you need to know is that this right here is the system that the tutorial models, and so we're going to go through that. So the point where this tutorial starts is going to be on 1.4.1, creating a new system in V-Hab. So the goal is that by the end of the tutorial, we're going to be able to run our first simulation in V-Hab. So the first thing you're going to want to do is you're going to want to go into your V-Hab folder, and you're going to want to create a folder for yourself. So to do this, go into the user folder and create a new folder, and use the first 2 initials of your last name and the first 2 initials of your first name. So for me, that's LABR. You can also use any other designation or shorthand that you want, but this is the one that V-Hab recommends using, and I also recommend using it as well. Also, forgot this at first, but you're going to want to include a plus in front of your shorthand. If you read through the previous folders beforehand, you'll know why this is important. pretty much it's just the way V-Hab accesses folders. You need to have the plus for it to be able to kind of read as it's operating. Once that's done, you're going to go in there and create a new project folder. So for this, it's going to be the introduction project. So you just type plus introduction, and you have then your new folder. Then for each project, you're going to need a systems folder as well. So plus systems, and you have your file folder structure set up as much as you will for this part of the simulation setup. Once you have your folder system set up, you can open MATLAB and get started on the actual V-Hab work in MATLAB. Now, if you have two monitors, I'd recommend using both of them, maybe having MATLAB open on one screen and the tutorial open on another. For me, I do have a setup like that. I'm just only screen capturing my V-Hab window at the moment because that's all I think I need. So once you have V-Hab open, you're going to want to make sure that you're in the correct file directory that contains V-Hab. You see here I have my V-Hab folder. I'm going to open that, and then once you're in this folder with your overall unzipped folder, you may have it renamed, you're going to want to right-click, add to path, selected folders and subfolders. This is important so that the program can access everything it needs to access while it's running. If you don't have this, it's going to have access issues and you're just going to have a headache. I know I did. And so you're going to do that until it's all finished up. This folder symbol will go from somewhat translucent to more opaque, bright, and that's when you'll know that it's finished. And then you can double click on that and it'll bring you into kind of the V-Hab folder. It may take a little bit of looking around to find what folder everything is in, but if you set it up correctly and you know where to find it in your file system, it shouldn't be that hard to find it in MATLAB, especially if you have any experience working with MATLAB already. So the first step, now that you're in here, is going to be to create your system file. So to do this, you can just do new script. And then you're going to take the code given in in section 1.4.1.1 system file from the wiki tutorial system and copy and paste that into MATLAB. So I'm doing that now, and you can see here this is the code that you should see copy pasted. And then so right away I'm going to save this as my system file. So it'll default to opening up the folder that you have opened up here on the side. And this system file, in this case, will be called example.matm because that's the file name that you completed, file name that you copied over here in this class definition. If your file was named something else, the class definition would be different, and you'd have to change things in other files, and you'll make sure to do that whenever you create a non-example or tutorial file. So where you're going to save this, you're going to go into user, you're going to be going into your file that you created in the last step here, and this is going to be saved in introductions and systems. So looking through the example file, you're going to see a couple different functions. This first function kind of sets up the file as a whole, and this right here is where you can change the time step that the simulation runs at. Next is going to be the create matter structure. This will be where you kind of define what the system that you're modeling looks like in terms of what components it's made out of. And then this solver structure here is going to be used to more or less define how the simulation, again, solves the equations that you give it. So the first thing you're going to do here is you need to have a system to solve, so you're going to edit the create matter structure. So you're going to want to leave this line that's in there by default, and then, you can copy the code given in the tutorial, and what this does is it creates two things. One is a store called cabin, and the other is a phase in the store called cabin air made out of nitrogen. And this is a gas phase, and that's pretty much all you need to know at this point. Is now you have a store called cabin and a phase in the store called cabin air. Once you've added the cabin air to the example file, we're actually done with this file for now, and we're able to move on to the setup file. So once you're ready for that, you can click New, Start a New File, and then copy and paste the setup file code from the wiki into MATLAB. Once you have that, you're going to save as again, and again go to User, Your Code, and Introduction, but this time you're not going to save it to the systems file, only to the general introduction file. And here you can see this is set up, split into multiple functions again. Your setup file, your configure monitor file, your setup function, your configure monitors function, and your plot function. To make your setup file usable for a V-Hab simulation, you're going to want to copy and paste the empty setup file template from the wiki and make sure everything is properly tabbed over so that it can be used in this simulation. And I copy and pasted that wrong, so you're going to want to overwrite this setup function right here. So the important things are here that you're going to need to work with. This XXYY you changed to your personal kind of shorthand that you used up in your file designation. And this right here is the kind of system name that you give it. So this is our introduction system, so we're going to leave it as is. And then this right here links to the kind of example file that we just set up previously. So here it links to, for me, labr.introduction.systems.example, and if you look at the pathway over here, that's exactly where example is located. It's under labr.introduction.systems.example, and you're going to want to stay, though, in this overall V-Hab folder. You're not going to want to go in here, otherwise you won't be able to actually execute V-Hab. And you can see here we have the setup and example files here in this side file browser. Other things to note here are your simulation length. This is, of course, how long your simulation runs for. In seconds, pretty self-explanatory, and you're going to want use time to be true. Other than this, we of course have configure monitors, which sets up the plotting kind of characteristics, and then the plot function, which actually makes the plots. So if you copy and paste the configure monitors function, you will get this, and again tab over as normal, and you can see here it adds the values from your example cabin air pressure in this case. This right here will be kind of pointing to the specific variable that you want to, or the specific phase that you want the plotter to access. This here, F pressure, will be the specific variable in V-Hab that it logs. This will be the units, and this will be kind of the name on the plot of what it will try and display. And then after that, the only thing left for the setup file is the actual plotting details, which I'll just copy and paste in here quick. And you'll see here, it's a bit longer, but not particularly more involved than any of the other sections, taking me a bit to find where the area to tab is, but that's alright. And it's all lined up and we're good. So as you can see here, it closes all the plots, make sure there's data to actually plot, and then sets up the plots. Here it's only making a single plot in a single figure. So first you're going to want to define all plots that you have. In this case we have a plot called total cabin pressure that reads from this these values over here, total cabin pressure. And then it also has a single figure, as you can see here, which reads from total cabin pressure as described here. And then once you have this and you save it, you are actually already able to run your first V-Hab simulation. And to do this, you don't hit run because that'll give you an error, as you can see. Instead, what you're going to want to type is, oh, not there. You're going to want to go to this command window, and you're going to want to type vhab.exec, that's EXEC, and then in parentheses and single quotes, you're going to put your shorthand, what for me is my 4-letter personal label that I have on my file structure, and then .introduction, because that is the folder that I have everything in, and then you're going to want to do .setup. And what this will do is this will run V-Hab through this setup folder that you may remember already calls that example file that we set up previously in systems. And when you do that, it'll initialize V-Hab and run it, and it'll take a couple seconds, as you can see here. But when it's done, it will have completed a full simulation as you've described, based on your V-Hab system. And sometimes you will get errors like this. So I think this is a useful, very useful example of how to do debugging. So after going back and looking at the program a little bit, I found what the error was, and in this kind of case, looking at this kind of sidebar here where we'll show you where some errors may be arising. In this case, the error that pops up is class def might not be aligned with its matching end, which tells you that these kind of ends is where you want to look for issues. So if that's the kind of issue you get, you want to make sure again that each end is lined up properly. So this function and its end are lined up, function and its end are lined up. And here you can see this end is there, but this isn't. But you may notice that you don't want class def to end right here. So this would not be the correct solution to this problem. Instead, you may notice there's actually an end down here, and you want both methods included in the class definition. So what you're going to want to do is delete this one. I may have copied something wrong at one point when copying these functions over from the tutorial. And once you do that, you can resave it and execute V-Hab. And now that this is done and fixed correctly, it should run the simulation, and it'll show you here there are these, I'll pull it up here. You'll see the simulations run, and it'll kind of give you an update at each time step that it runs, give you some basic information about the simulation. It'll give you the matter balance, and that's all it gives as a normal output for this. However, I promised graphs. This is how you get graphs. So you'll see over here in this workspace something called OLastSimObj. So you're going to type that into the command line, and then follow it up with .plot. It'll say no data outputted yet, but then what it'll do after a few seconds is it'll pop up with the plot that you commanded it to make. So you'll see here this plot that we designated earlier with total cabin pressure, time in seconds, and pressure in PA, pascals. You can see it runs for all 3,600 seconds. And you have just a single line, since there's no reason that the pressure would be changing at any point in this simulation. Now, this is very simple at this point, but it is your first sim in V-Hab complete. In future videos, we'll be going over more in-depth of how to improve the simulation, how to add more stores, phases, processors, and eventually create an entire working spacecraft simulation. But for now, that's all I have. Best of luck, and I hope you enjoy the first video of the V-Hab introduction. Thank you.